Hi, my name is Tim Lindquist. I'm a professor in the software engineering program at ASU. And this is a video in support of our course SER423 on mobile applications. This is a video that supports the Unit 9 on persistent storage on iOS, and in particular using iOS's mechanism for core data as well as SQLite. So this is Unit 9 under persistent storage, and you'll see several different references. No textbook references. The textbook is only an Android textbook, but there are several references that exist on the schedule page that refer you to examples and tutorials on using core data and also using SQLite. The same version of SQLite is available automatically on iOS for iOS applications, as is available on Android. However, in iOS, it is present in the C binding for it, and obviously not Java. And Apple has not yet created and released a Swift binding to SQLite. We have an example that does access SQLite using a framework that is commonly used within the community of iOS developers that use SQLite. And I want to show that, and I also want to show use of core data. So let me describe for you core data first, and then we'll go ahead and take a look at the example that uses core data. Core data is Apple's object management system, I think is a better way to describe it than a database management system, that allows you to persist data as managed objects within an iOS application. Apple provides, or Xcode provides, a design mechanism for you that it does a very good job of allowing you to define tables or entities, as well as relationships between entities and other characteristics that are typically defined within a database, but it supports viewing that data as objects, primarily as objects, as what are called managed objects, and it handles for you caching as well as saving and restoring. The other advantage of using core data is that, in fact, it is integrated with iCloud. So if you're developing an app that will store data on the cloud using Apple's cloud, then in fact core data is a very good choice. So the first reference from the schedule page is Apple's description of how one should go about persisting data and using the cloud, iOS data storage guidelines. And you can tell that, in fact, they're very interested in seeing you use the cloud, and they describe it as a primary mechanism for doing that. The second one is to the core data programming guide. It is very well done, and in fact, of course, it is a little bit salesmanship, I guess the right way to put it. They obviously project the advantages of using core data, and there are several. Don't mean to say that there aren't. It's actually a very well thought out and very well implemented set of facilities. That doesn't mean that every app that needs to persist data should use core data. In my view anyway. You may develop a different view, but it goes through some of the reasons why one might want to use core data, and then actually it goes through a description of using core data facilities. So that's the second one. Ray Wenderlich has developed a very good, actually it's progressed over several years as core data has been refined and as languages have changed. Initially, his site provided a tutorial using core data with Objective-C. I think that's probably still there. Now there's a very good one even with the most recent version of Swift for core data. And then there's somewhat of an older reference to a Dr. Dobbs page that kind of show you here, that I think I view it as kind of mandatory reading that gives you an idea of both sides of the coin. It actually looks at comparing using core data with SQLite. This actually is, you can see, this is from August 2014, so by our standards that's pretty old. Nevertheless, it goes through a comparison of using SQLite with core data in a given application, and it tests that application with lots of data and kind of publishes and shows you, going through how you go about building it, and also shows you some of the reasons why you may want to use one as opposed to using the other. So I encourage you to read, in particular, read the Dr. Dobbs article. You'll probably see that if you're in the class. You'll see that in one of the exams coming forward. One of the statements that's made in that article is that if you're developing a native app that does the same thing with two different code bases, one on iOS and one on Android, if the Android app uses SQLite, then there's every reason why you should use SQLite on the iOS app. It makes the enhancements that you make to both platforms kind of parallel with each other. Obviously, there's many other things that one needs to consider just besides just maintainability. Nevertheless, I think it's a very interesting comment that they make, and probably one that is very appropriate. So then the last reference is doing relationships in core data. So let's go ahead. So you'll see that doing the relationships is done in a different manner than the way we do it typically in SQLite, and consequently there's a special section that treats that. So let's take a look at the app for doing core data in Swift, and we will kind of read it. So with core data, it does not make any sense at all to initialize your core data repository from a database that comes in with the bundle. And instead, it's better to do that with code. So you notice that the project does not contain any equivalent of our courses database, .db, as we had in the Android. But it does have, when you create the project, when you create a new project, there is, let's just go ahead and go through it so I can show you where it is. If I'm creating a new project, just do it as a single view application. Notice that on the second screen, there is use core data. So if you want to use core data, actually there's tool support that comes in both to the project itself, to the files, and are used within the Xcode editor. That's an important selection to make, and I made that when I developed this example. What do I get with that? It's primarily this student course core data.xc data model. And this is a tool that's available to not only create, but also to diagram for us schemas. So in this case, you can see I have created a student entity and a course entity, and the student entity has an email, a major, a name, a student number. So if I want to create a new entity, I do that with an add entity. It'll create an entity for me without a name, all right? And then when I select that entity, I can add to it attributes, all right? So I could add an attribute, and when I add an attribute, I can select the type of that attribute and so forth. So I'm just going to remove this guy. Now, maybe it's not going to let me do that. No, I don't need the helper. I do need help, but I don't need the helper. There we go. So those are the two major things that one has are entities and attributes within those entities. The attributes are essentially columns or equivalent of columns in a relational database. We can also define relationships, and we can define fetched properties. Relationships, so with students, there's the courses that a student takes. So I've defined a takes relationship. Its destination is the course entity. There's no inverse, which means that from a course I can't find out all the students that are taking that course. Yeah, in another application I'd certainly want to do that, but in this application that's not what we're doing. And also show you that associated with relationships and entities, we get an addition to the inspectors, and that is one that allows us it's this guy right here, I already had it, the data model inspector, that allows us to look at attributes that are associated, in this case with the relationship. So in fact, the destination, its inverse, a rule for deleting it, right? So instead of nullifying, I could take no action at all when a takes relationship is removed. I could take no action. I can nullify it, and so forth. Cascading, all right? So you can see there are options that are available for relationships as we go and define a relationship. And in particular, one of them that you need to set, you can't set it under the relationship itself. You need to set over here is the too many, the type of relationship. It could be a 2-1 relationship, or it could be too many. Too many meaning that a single student can be taking multiple courses instead of just one course. So the too many type is added to that relationship. So in addition to this model, we have the ability within our code to be able to access elements from that database. And we access them as, I think I've showed both of them up here. Let's see. Yes, I did. In this particular app, let's go ahead and execute it. iPhone 7. We have two different pickers that are being used. One picker is for students, all of the students that are registered in our student entity. And the other picker for a given student that we've selected, it will tell us the courses that that student is taking. So the data sources for those two pickers are within my view controller here. I only have a single view controller. Notice that in this case, it's not initialized to have any new data, so let's enter some data. And I'm just going to add the student without any courses. And let's add another student. And notice that the takes for Joe, so now under my, when I check the student, when I select the student text field, it gives me a picker of all of the students that have been registered. And when I select a different one of those students, it displays the data for that particular student. And the takes is empty because I haven't added any courses to either one of the students. So let's put Tim in SER423. So you can see that it shows up in that picker, right? So now when I go back to Joe, nothing there, no takes. When I go back to Tim, my takes is appropriate. So I'm not going to spend a lot of time reading this. You can see the access. I did want to say that related. So the data sources for both of those pickers. The data source for the takes picker is this array of strings, where the string is the name of the course, and the data source for the students picker is an array of managed objects. Right? So in fact, if we go down and just take a look, I'm not going to do much more than that. You can see there are update the takes picker. Here's an example of a select request. And we can develop a predicate for it. So in this particular case, I'm going to be selecting from student, where the name is, in this case, a particular student. And then I have an iteration that for all of the students that get returned, things that I'm going to do for that student. I want to go down here to the data source, and that data source, this has a lot of code in it. But for each of the pickers, I have this class listed as the data source for both of the pickers. So within the methods for the data source of those pickers, I have to decide which picker I'm working with. There's two different pickers. So if the picker view is the takes picker, here's what I'm going to return for it, for which component it is at a given row. And if the picker view is the student's picker, then this is going to give me the name of the student. All right? So remember that takes is an array of strings, which are the course names. They're set up appropriately. You can find that out in the code. And the student's array, is an array of managed objects. So this kind of shows you how you access information within a managed object. So here is a student.value for the key name as a string. All right, so cast it to a string. And if you go back to our data model, if we look at the name attribute, all right, the name attribute for the student entity, you see that it's defined to be a string, so I know that I can always cast it to a string. Okay, let's not go any further than that. I want to show you at least one more of these examples, and that is in Swift using SQLite. So let's just quickly take a look at this one as well, and then I'll just describe the third one. We won't actually go through it. So again, open it up with Xcode. Now, I want to show a couple of different things about this example. First of all, let's take a look at the comment section. Typical Lindquist stuff, open sourcing it. But the purpose includes quite a bit about using Swift. In this case, we're using SQLite, a SQLite binding to Swift that has been produced by Stephen Sellis. He has a GitHub site that I've downloaded it from, and actually there should be a reference in here someplace to that. Yeah, there it is right there. Let's open that up. So here's the GitHub site. I've downloaded it, but I will point you out if you decide to use this in going through one of the laboratory exercises, it shows how to bring in an auxiliary framework and include it in your project. In this particular case, there's quite a bit of code and a number of classes that are associated with this Swift binding to SQLite. As I mentioned earlier, Apple will provide you with a C binding to SQLite. That's not very convenient to use from Swift, although it can be done. The third example that's posted on the schedule page is an example of using that C binding from Objective-C, which in my mind is a much closer to the use of that. There's no reason why one wouldn't. Objective-C and C, Objective-C is an extension to C. So here it also gives the usage for it, as well as, I thought here was, yeah, here's the installation. So it goes through 3 or 4 different ways to install it. One of them is using Carthage. The next one is CocoaPods. Then there is also the Swift Package Manager as well. And what I did was to follow the manual method to actually bring it into my project. So I downloaded it and then built it under Xcode, and then I just dragged it into my project from Xcode and selected it. So one has to go through that exercise in order to use an auxiliary framework. That's described here in these steps 1 through 5 that describe how to bring it into the project. And when you do bring it into the project, then in fact you can see here's the SQLite Xcode project that was created by going through those 5 steps. With that being done, I can then within the view controller for any one of my classes, I can access the SQLite package, and for some reason or other it's not I'm going to have to check this out. This is probably the first time that I've downloaded this, so I will check it out and see. It may very well be that it is not included within, I probably brought it in by reference as opposed to copying it in, which means that you'll have to go through those 5 steps in order to get this thing to execute as well. Once you have it successfully installed within your project, then you can import SQLite, and I can tell you that I'm not going to execute it properly from here. Let's go ahead. And let's get out of this project. So here you can see it shows up not in red, so it's available here, and let's go ahead and run it. So you can at least see how it works. In this particular case, I have already provided it with the exact same database file. Course DB. I've changed its extension to SQLite 3, but that is the same database file that we looked at in the Android example. And this example is very similar to the Android example. It provides those exact same 3, the ability to add new students, to change the courses that are taken by a student and so forth, and it shows you in the code how to access a SQLite database from Swift using the Swift binding to SQLite. Okay, let's leave it at that, and I will end with a brief description of our last example. I already mentioned, so this example uses the C binding to SQLite in the Objective-C language. Objective-C is C combined together with object-oriented, very similar to the way it's done in Smalltalk. It's actually a very good, very well done language, although it did not get wide adoption, partly because of Apple and partly also because not everybody knows both Smalltalk and Objectives and C. But in fact, it's a very good systems level language, and this demonstrates using SQLite from that. The exact same app should be the exact same view for the app as with the SQLite, which is very similar to the core data version. Okay, very good, thank you, and I'll see you next time. The next time we'll be talking about doing media mapping and location services.